Gravity, or the gravitational force, is something we've talked a little bit about um, so far. So it depends on the object's mass and the value of little g. So you can go ahead and use 10 newtons per kilogram if you'd like. You can also be more official and use 9.81 or 9.8. Again, that is a choice. It's fine either way. It's really important here, though, to think about that g not as an acceleration, but rather a ratio between mass and weight. So we're not saying that the object actually moves or even accelerates at 10 meters per second squared. What we're saying is that for every 1 kilogram of mass, there is a force of about 10 newtons pulling it towards the Earth. Some things to keep in mind with gravity is that it should always point directly downward in your diagrams, regardless of what's happening to the object. It will be a part of just about every single problem that we do, unless the problem mentions that the object's mass is negligible or it can be ignored. Watch out for thinking that the gravitational force is equal to 9.8. That is not at all what I'm saying here. The ratio between mass and weight is 9.8. So it depends on how many kilograms we're working with. And g itself is never a negative number. When an object is only under the influence of gravity, then its acceleration is g, and we often consider down to be the negative direction. So all of those things come into play when we plug negative 9.8 into a formula. But g itself, little g, is a positive value of 9.8.